Good morning, physics students. Hey, it's Mr. Finn. I'm in the lab today, and I wanted to do a quick demonstration for you guys regarding Galileo and his thoughts on free fall. Now remember, Galileo was kind of an avant-garde type of a personality. He was really out there, but he had some really cool things going on. He revised the telescope. So he took Tycho Brahe's creation and made it much, much better. So he could see the heavenly bodies, the Mars, the Jupiter, the Venus. Anyway, one of the things that Galileo suggested was that all things fall at the same rate. All things fall at the same rate. Now, there was a caveat to this. There was a little exception, a little precursor. And that precursor was this. You had to be in an environment that was devoid of resistance, devoid of all medium. Because we know that if you drop a kind of a cardboard rectangle and a piece of paper in the classroom, like I'm doing here, that most people would say, well, Mr. Finn, the cardboard's obviously going to fall quickest to the ground because it's heaviest. And of course, that's exactly what happens. But one of Galileo's close friends, Giuseppe Moletti, I'm not kidding you, the guy's name is Giuseppe Moletti. Giuseppe says that Galileo, well, what if I do this? What if we put the paper under the rectangular cardboard? Or in this case, it was a wood board. Okay, well, most of us would say, Mr. Finn, Galileo, Giuseppe, obviously the heavier board is going to push down on the piece of paper. So they might fall closer to the same rate. This is brilliant because yes, the weight of the board pushes the paper down to the ground. Okay, no problem. But in order to prove Galileo's hypothesis that all things fall at the same rate in mediums totally devoid of resistance, we need both the paper and the cardboard to reach the ground at the same time, but not in a way that the cardboard, or the board in this case, is forcing the paper down, because that was consistent with something that Aristotle said way, way back in the BC times. And he would say, hey, you know what? Propulsion minus resistance, that is the law of motion. Well, it's not quite as easy as all that. Here's Giuseppe Moletti for the third time saying, hey, Galileo, show him this. What if we put the paper, which is much lighter, on top of the board, and we let him go? Well, most people would say, Galileo, Mr. Finn, Giuseppe, obviously the paper's going to fly off and the board's going to fall down because the board is heavier and the paper has nothing to propel it to the ground. There's no weight. Aha. But when Giuseppe lets it go, what happened? What happened? Bada boom. Bada boom, bada bang. Wait a minute. The paper sits on top of the board and falls straight down. Like a stone, the paper falls to the ground like a stone. The same as the board, as if there was no air resistance whatsoever. In a medium totally devoid of resistance, all things fall at the same rate. All things fall at the same rate. That rate, we just happen to know, is the rate of gravity, 9.8 meters per second squared, or 10 meters per second squared if you want to get a smaller or a more generalized version of that. Giuseppe, brilliant. Galileo, brilliant. And we're going to do more with this, guys, but wanted to show you that demonstration. And it's quite easy to do here in the lab when I've got cardboard, kind of a rectangular cardboard piece that's about just roughly the same size as paper, a little bit bigger. Okay, guys, Back to the classroom material.